So if I want to perform the given operation, and I am going to start with number 2. So that one's the second one listed on the poll. We are again working with just complicated fractions is what we have here. Yesterday we talked about how to add or subtract fractions. Today we're talking about, well, what happens if you're dividing one by another, but maybe it doesn't look like what we have traditionally seen as division. What if, for example, you're given a fraction line? So that's what this is. This is a fraction line. Thankfully, if that's all we have to deal with, this one is not too bad. That means division. So that means that I am going to write the top fraction as is, keep the top fraction. And then I'm going to change that division to multiplication. So instead of a fraction line, I'm going to multiply that top fraction by something. And what I'm going to multiply it by is the reciprocal of this bottom fraction. So I'm going to flip the bottom fraction. So it becomes 4 over b squared instead of b squared over 4. And we know how to multiply fractions. Multiply the tops to get the new top, or the numerators together, and then multiply the denominators together. 12 times 4 is 48. A just gets tacked on to the end. And then b squared times b to the, or excuse me, b cubed times b to the second becomes b to the 3 plus 2 power, which is b to the 5th. So most of this was recognizing that that fraction line means division. If I can recognize that the fraction line means division, then I can rewrite this as multiplication of 2 rational expressions or 2 fractions, and that allows us to simplify. Questions on that one? Yes, we're working on the 7.5 today. Sorry if that was not clear. Typically, if a particular section is assigned for the day, that means we're going to go over it in class that day. So you should try to watch the video for that before class, so the night before or the morning of, and then work on some of the homework at least. Other questions on that? And I apologize if my PowerPoint was incorrect yesterday. I don't remember 100% what it said, but I think it said watch 7.5. All right. Let's do the next one. Got it. Okay. Just seeing the chat. Yes, when I said watch 7.5 tomorrow, I meant for tomorrow's class. But that's okay. Today is another day. You can just keep up in class and then watch it afterwards. No big deal. What if we are faced with an expression that looks like this, where we have a combination of division, so that fraction line means division, and then we also are throwing in some addition and subtraction. We do want to lean on what we did above and note that we can change division of a fraction to multiplication, but that only works if I have a single fraction, top and bottom. So up here I have a single fraction. Single fraction on top, single fraction, top and bottom. So 1 fraction in the numerator, 1 fraction in the denominator. If we were able to get 1 fraction in the numerator and 1 fraction in the denominator, we could go back to the process we just talked about. But I think that's manageable. So I'm going to consider this top portion and the bottom portion separately, just for the moment. We know how to add fractions, how to add rational expressions. If we added or subtracted rather the two fractions on top and then added the two fractions on bottom, we would have a single fraction on top and a single fraction on bottom. So that's going to be our approach. I'm going to take the 1 over x squared minus 3 over x, and I'm going to note what the least common denominator is. This denominator, first denominator is x squared, which is x times x. Second denominator, there's a single x. Therefore, my least common denominator has to involve two x's. There's certainly a single x in both, but one of them I have a second x. So my least common denominator is x squared. That first fraction already has a denominator of x squared. Second fraction, though, needs an extra x on bottom. So I'm going to multiply by x over x, which gives me 1 over x squared minus 3x over x squared. Now I can note that I have the same denominator for both of these fractions. Therefore, I can add the tops, or subtract rather. 1 and 3x are not like terms, so I can't combine them into a single term. I just have to leave them like that. So I'm going to replace my numerator with 1 minus 3x over x squared. This is now a single fraction. I'll do the same thing with my denominator. I'm going to consider 3 plus 1 over x squared. And I can note that the denominator of the 3 is 1. If one of the terms that I am adding to a fraction is a whole number, I can essentially kind of ignore that denominator when it comes to finding the least common denominator. My least common denominator here is that denominator of the second term, x squared. So that means 3 over 1, I have to multiply by x squared over x squared in order to obtain x squared on bottom. Second fraction already has that least common denominator. That gives me 3x squared over x squared plus 1 over x squared. So that is adding two fractions that have the same denominator now. So the result gets that common denominator. The numerator is the sum of the numerators of both fractions. Okay. So that I'm going to replace the denominator of this fraction by. And now we have a single fraction in the numerator and in the denominator, which is a little bit of work, but it allows us now to rewrite this as multiplication. I'm going to write that first fraction, 1 minus 3x over x squared. I'm going to change that division, or that fraction line, which represents division, to multiplication. And I'm going to multiply by the second fraction, the reciprocal, rather, of the second fraction. X squared over 3x squared plus 1. Okay. I'm going to try to simplify before I actually do that multiplication. It looks like I cannot factor my top or bottom of either fraction, but I can note that I have a common factor. I have an x squared. That's being multiplied by the top and the bottom of both fractions. So I can cancel that common factor of x squared. That gives me 1 minus 3x remaining on top, 3x squared plus 1 on bottom. And that is my final factored form, or final simplified form, I should say. I want to, oh, it is recording. Look at that. I'll just post the part that we are doing right now, though. So again, fractions. Anytime that we are working with fractions, I again have a combination of division. So that's what this fraction line indicates. That's division. And then I also have subtraction, top and bottom. It's easier to work with fractions if I have a single fraction that I'm dividing by a single fraction. So I'm going to start this problem by working with the top and the bottom individually. And this is how your regular instructor showed you in the videos. So I'm going to work with each of those individually and subtract, and that will combine two terms into a single term and allow us to apply the division. So I'm going to start with 5 minus 1 over x. 5 has a denominator of 1. Whenever one of the expressions I'm adding or subtracting has a denominator of 1, I can let the least common denominator be the denominator of the other term. So we're going to let x be my least common denominator. 1 is a factor of everything, so it doesn't really come into play much when we find the least common denominator. So 5 over 1, I want to write with a denominator of x. If I multiply 1 by x, I get x. I can't do that, though, unless I multiply the top by exactly the same thing. So there's the first term. My second term, I don't need to change because it already has the denominator of x. So my first term, 5 times x is 5x. 1 times x is x. Minus 1 over x. And now I can look at what I have and note my denominators are the same. Whenever my denominators are the same, I can subtract. I get a fraction with that common denominator, with the same denominator as the two fractions that we started with, and then I can subtract the tops. 5x minus 1. That 5x and the 1 are not like terms, so I can't combine them, but I can write them as the numerator of the fraction. So creating a single fraction to work with. So I'll go ahead and write that in. This becomes 5x minus 1 over x. Great, that's the top. We just simplify the top. Let's work on the bottom. 4 minus 1 over x. We can again note that the denominator of the 4 is 1. If one of the two terms, I should say, has a denominator of 1, then I can use as my least common denominator the non-1 denominator. So I'm going to use x. I'm going to rewrite the this first term with a denominator of x, which means I have to multiply the bottom by x and multiply the top by x. That second term doesn't change, though. It already has a denominator of x. So we multiply, we get 4x over x minus 1 over x. Now we're at the point where both denominators are the same. So we can add. The new fraction will have a denominator That is x. And then I can subtract the tops. Again, 4x and 1 are not like terms, so I can't combine them any further than that. And I just have to leave it as 4x minus 1 on top over that single denominator of x on bottom. So there's step 1. We combine terms. We wrote the terms on top as a single fraction, wrote the terms on bottom as a single fraction. Once I've done that, I can rewrite this division, which is what that fraction line is, as subtraction. So the top fraction we keep, 5x minus 1 over x. The division turns to multiplication. And then the bottom fraction, we write the reciprocal. So instead of 4x minus 1 over x, it's x over 4x minus 1. We flip the fraction. Okay. And now before I multiply, I'm going to see if there are any common factors in the numerator and the denominator. It looks like there is a factor of x that will cancel. That is being multiplied by the top and multiplied by the bottom. Therefore, I can divide the top and the bottom by that, leaving me with 5x minus 1 over 4x minus 1. There's my simplified form. Any questions on that one? Okay. Let's move to the next one then. The next one is actually a little bit quicker. Let's do number 25. Number 25 looks very similar in setup, actually. So we could combine the terms on top and combine the terms on bottom. So let's go ahead and do that. There is a shortcut here, but since we're talking about these types of expressions where you want to add, subtract, and then change division to multiplication, doesn't hurt to practice this. 2 minus a over b. 2 has a denominator of 1. Therefore, just like the last one, my least common denominator is the denominator on the right, which is b. So 2 over 1. I want to write with the denominator of b. So I'll multiply by b over b. Subtract a over b, which gives me 2 over b minus a over b. My denominators are now the same. So I have a new fraction with a denominator of those two original fractions. And then the top I can write as 2 over a. Oops, I missed something, didn't I? This should be 2b. 2 times b is 2b, which means I have a 2b up here. So that becomes the numerator of this fraction. Okay. This second expression is almost the same. We're just subtracting the 2 instead of subtracting the a over the b. So my least common denominator will again be b. So my first term does not change. My second term, however, I have to write with a denominator of b. So I have to multiply by b over b. So that gives me a minus 2b over b. Okay. So it becomes the denominator. Oh, I skipped a step. I should go ahead and show this step. This becomes A over B minus 2B over B. There we go. Here, the terms have the same denominator, which results in A minus 2B over B, which I am actually going to go one more step, but I'll show you why. I've got A minus 2B over B, which I can now rewrite as multiplication. 2B, let me keep the blue color here. 2B minus A over B times the flipped fraction B over A minus 2B. I can note here that I've rewritten it as multiplication. I have these common factors, B and B. And then I can note that these remaining factors, we haven't been able to cancel those thus far, but we've seen a situation like this where these are almost the same with the exception of a sign. So if instead of writing this term on bottom as A minus 2B over B, what if I factored out a -1 from the top, which will give me negative A plus 2B over B, and that will switch the signs. So let's go ahead and make that modification here. Oops. I'm going to change the top of this, and I'm going to change the bottom of that, and write it as this -1 times negative A plus 2B, or -1 times 2B minus A. It's another way to write that. And then I have this common factor of 2B minus A that will also cancel, which gives me remaining on top is a 1. On bottom is -1. So -1 is my result. Right? Happy to answer questions about that in a minute, but I want to at least begin this next one, just so you see it. Because we work it in exactly the same way. I have division of a sum, or a difference by a sum. So I'm going to take this 1 over d squared minus 1 over c squared, and I want to find the least common denominator of the terms. It will be c squared d squared, or d squared c squared. So 1 over d squared, we want to write with a denominator of c squared d squared. It is missing the c squared term. And then 1 over c squared. It is missing the d squared term. So that will give us c squared over c squared d squared minus d squared over c squared d squared. Okay, so now I have this common denominator. And I can write the fraction with that common denominator and subtract the tops. It's that top expression. I can replace 1 over d squared with c squared minus d squared over c squared d squared. No worries. I was just about to stop and know that we are out of time for class. So I'll pause with this one. I suggest you try to go finish it on your own. We got that first fraction rewritten. You're going to do the same thing with the second fraction and then change to division. But I will go no further with it because we are at the end of class. Selena, are you talking about videos that Hannah posted or videos that that we've recorded in class? Because I haven't posted any videos that I have recorded due to the fact that Hannah has hers. I can certainly post some of them, however, if you'd like to see some of them. Like this one, for sure, I could post, and stuff from yesterday, I could definitely post. Just let me know.
Are you going to continue with this problem? Or...
Yep, we can continue with it for sure. Okay. I can look back at the recordings that I have in Zoom, like the ones that are still active at least, and I'll see if I can post the ones that we've worked through. And we can also finish this problem. But for those of you who have to leave, have a good weekend, and I'll see you on Monday. And for those of you who want to stick it out with this problem, we can finish it. Okay. I think I need more room though. Harvey, what do you mean double check the schedule? Do you mean you want to ask me about your schedule, or do you want to double check to make sure that you don't have anything after this? Because the schedule for, if it's the former, the schedule for Monday is we're going to go over 7.6 in class. So I recommend that you watch the 7.6 video and go over some of the homework beforehand. And then we will hash out some of the homework in class as well.
Is there a way to like organize this problem a little bit better so I can understand it better? Because once it starts getting that long, it kind of confuses me.
Some people prefer to do it vertically. So you could do it that way if you want to. So as we continue this problem, we could try vertically. I honestly usually write my problems vertically, but there's not a lot of room here. So I started doing it horizontally, but we could certainly do that. So we did say that the least common denominator was d squared c squared, or c squared d squared, whichever you prefer. So as we are rewriting everything with that denominator, we could write everything out vertically.
We're on the bottom half now, right?
I'm rewriting the top out vertically, sorry.
Okay.
Minus 1 over c squared times d squared over d squared, which is equal to c squared over c squared d squared minus d squared over c squared d squared. And then the bottoms are the same. So I can subtract the tops, write them all over that same denominator, c squared d squared. There are other ways you can organize this, Kaylee, but does that help?
Yeah, this way makes more sense to me.
Okay, great. Good to know. We'll do the next one that way too. Okay, now Kanisha, we're moving to the bottom. So I want to note that if I have c over d squared plus d over c squared, I want to write those as a single fraction. So I want to find my least common denominator. And it has to include the factors of both denominators. Looks like it is again c squared d squared is my LCD. So c over d squared, that's missing the factor of c squared. So I'm going to multiply the bottom and the top by c squared. Just have to wait until my PDF saves though. Okay, plus d over c squared. Looks like that one's missing the factor of d squared on bottom. So I'm going to multiply the top and the bottom by d squared. So let's see, c to the 1 times c squared is c cubed over d squared c squared or c squared d squared. I can write those in either order. Plus d to the 1 times d squared is d cubed over c squared d squared. Okay. We've simplified our fractions. We can note we have the same denominator now. So we can now write as a single fraction with that denominator c squared d squared. And the top becomes the sum of c cubed plus d cubed. So that is the denominator expression. Let me change my colors here just to be consistent. Didn't do a good job of being consistent with my colors. So this is the bottom.
So would you flip it? When you flip?
Mm-hmm.
Okay.
Yep. It's c squared minus d squared over c squared d squared over c cubed plus d squared or d cubed over c squared d squared. And at this point, we would
Well, if you
want
flip it,
to flip it.
it'd be c squared over d squared, right? Over c cubed over d cubed, right?
Yes, exactly.
Okay.
So whenever you write it as multiplication, you will invert the fraction. So it'll be times c squared d squared over c cubed plus d cubed.
Right. Right. I got that.
Okay. And I would immediately see that those will cancel because they're the same. I really need more room for this problem. Oh, I have more room. Look at that. Okay. So I would immediately see that those cancel.
Mm-hmm.
Now let's maybe write what remains and I can do the rest vertically. So I have c squared minus d squared left on top over c cubed plus d cubed. The previous problem, we haven't been able to do much more cancellation than that. We saw in the previous problem, we could cancel out by factoring out a -1. This one, though, we could maybe do some more involved factoring.
Quick question. On the bottom where it's cubed, why would you put a plus sign? Because it was already c cubed over d cubed. So why would you put a plus sign there?
So here,
No. C squared minus d squared over c cubed plus d cubed. Why would you put the plus sign in between there?
that comes from here. So this plus sign, it stays in
What
here.
I'm saying is, so we, no, oh Lord, this is where I'm confused. Okay, because we haven't been doing the bottom part. See, Oh, okay, hold on. Yes, we were. The C3. Okay, we flipped it. So before we flipped it, it was. I think I'm confused right there. I don't see where we did that. I guess I didn't do that. Okay. Because does that matter? That plus sign being there? That's a big. Is that
It does matter.
okay?
When we went from the two separate fractions here, c cubed over c squared d squared plus d cubed over c squared d squared,
Yes.
rewrote them as a single fraction.
Yeah.
They have that common denominator of c squared d squared, but c cubed and d cubed are not like terms. So I can't just put them together. I have to write them separated by this addition sign.
Okay. I'm going all the way through the problem trying to see. Okay. Okay. So okay, so at the top, so and that one was okay a plus. Okay, so okay, I see where I made my mistake right there. Okay.
Okay.
Okay, thank you.
Uh-huh. Now that we've gotten that far, that's about, as mentioned, as far as we've been able to go for previous problems. But this one, I'm looking at the expressions on top and bottom, and it looks like they're factorable. Maybe I'll factor them separately. C squared minus D squared, that's the difference of two squares. So it'll factor as C plus D times C minus D. And then C cubed plus D cubed, that's the difference or the sum of two cubes. So it'll factor as C plus D. See if I can remember this. C squared minus CD plus D squared, I believe. Those go on the numerator and the denominator now. So we've done our initial cancellation. It looks like we might be able to do more here though. Ooh, lost some terms there. I'm going to put those top and bottom.
Can you flip it up just a little bit so I can see the C cubed plus D cubed? I don't
Can
know.
you see it now?
Yes, ma'am. I can see.
Okay. So I'm going to write the top in factored form. C plus D, C minus D. Write the bottom in factored form. C plus D times C squared minus CD plus D squared. And I can again note that I have common factors. I have the C plus D that will cancel, top and bottom. So I'll write what remains. C minus D over C squared minus CD plus D squared. And that's as far as I can go with this.
Okay. Okay. The bottom part, where's the bottom part is where did you factor out the bottom part?
That is right here. That's the difference of two cubes.
The red. Okay. So yeah, with my tablet is always it's in the way and I can't see it.
I understand.
Okay.
Grandma,
I'm in school. I'm in class. Okay. When I'm done, then I'll talk to you.
At the bottom, where is the CD coming from?
That's the difference of 2 cubes formula.
Oh, okay.
Okay. So that is the okay. So this is a C2.
Or sum of 2 cubes rather, not difference.
Okay. The C3 plus D3. Okay.
Other questions about this one?
Yeah, I'm still trying to write it down.
You're good.
Okay. C plus D. So see, when it comes to this, so I know you got this in your head, but I would have to go back to factoring how we did the factoring. I would have to go. So this
Yeah,
probably
I get
would be
that.
very long.
Grandma, can I have a
Yeah, I've been doing this for a while, so I just kind of automatically recognize, oh yeah, that's factorable. But this stuff will take practice to recognize that. I would say anytime you see an exponent that's higher than 1, you want to think, can I factor that? Are there any factoring methods that will allow me to do this factoring? We didn't really have that in the last 2 problems.
Oh, okay. I got it.
Is that enough, Kira?
Let's go.
Great. This is actually a really good problem. There are a lot of steps, but it gives you practice in a whole lot of different elements. There may not be one quite this complicated on the test, but you will definitely get to practice everything in this problem on the test.
I think. So what would be the ending? What was the answer? Because
The answer was this. C minus D over C squared minus CD plus D squared.
because we cancel stuff out. Okay.
Exactly.
CD. Okay, so there would be C minus D over C squared plus CD plus D squared. Is that it? Can you pull that up so I can see that? Is that what it is? Yeah, okay.
That one?
Okay, all right. Whew. So with doing these problems, we still only get an hour to do all these problems on the test.
Yes.
See, that's the problem too, because then you rush. It's like you rushing to do math. Like that's how you make mistakes.
Yeah,
That's
it doesn't seem like enough time.
that's another problem that I'm having is because I'm not getting all my exam questions completed in that hour. And so then I'm like having to hurry up and upload it and then having the uploading problems. It's like you set up to fail this class, honestly. I'm gonna be honest with you. Because you shouldn't have like a 1 hour window to do and all these steps and we're just learning.
I understand, and that's something that you could definitely present to your regular instructor.
Yeah, is there somebody
After
else
about it?
we can talk to? Because I know she's probably known that. Is there somebody else that we could probably talk to that? Because I've reached out to my academic dean about this class because I'm like, you set up to fail this class. There's no way that you coming in. I'm 20 years out of school, and I did a math 31 last semester, but then you just jump right in like what you're supposed to understand this. Like you guys are pros at this, but I just feel like this is you set up to fail. Like even in I can feel comfortable, but I do feel comfortable doing the problems on the test, but because I'm rushing, I'm missing stuff.
I get that. And, again, I think the two things. One, I gotta jump off here in like 1 minute. I'm sorry, I have something at 2. But I would say your regular instructor is probably the first one to contact about that. And then you'd probably want to talk to your advisor.
Okay.
But I would say you definitely always want to contact the regular instructor first. And her contact info, I believe, is listed on Canvas, and if not, it will be come next week. Okay. And Kaylee, I'm happy to do more problems at another time, but I'm sorry, I have to jump off. You're welcome. All right. I will post this recording at some point today, if you want to look through it. Otherwise, have a good rest of your day.